Black holes are the most violent yet most fascinating objects in the universe. They seem to contain the ultimate mystery of the cosmos. But what many people don't know is that black holes weren't first discovered through observation. They were predicted by a philosopher. That philosopher was John Michell from England, who first proposed the concept of black holes in 1783. Back in the 18th century, with limited observational equipment, it was impossible to detect black holes directly. But people already understood gravity and had measured the speed of light. Michell wondered, if you throw an object upward, it falls back because it hasn't reached a certain speed. If an object reaches 7.9 kilometers per second, it can escape Earth's atmosphere and orbit our planet. At 11.2 kilometers per second, it achieves escape velocity and breaks free from Earth entirely. At 16.7 kilometers per second, it can overcome the Sun's gravitational pull and venture into deep space. Following this logic, with sufficient speed, objects could escape our galaxy, then galaxy clusters, until reaching the ultimate limit, the speed of light. But if even light cannot escape an object's gravity, that object must have unimaginable gravitational force, swallowing everything including light itself. Michell named these objects dark stars. Though unobservable at the time, he believed the universe might contain such light-trapping monsters. This theory was so radical that most scientists considered it merely an interesting speculation. It wasn't until over 100 years later, when Einstein published his theory of general relativity describing how spacetime could be curved by massive objects, that the concept gained traction. According to this, extremely massive objects create deep dents in spacetime's fabric, like a trampoline bending under weight, pulling everything into its PID. Yet Einstein himself doubted black holes' existence, as they defied known physics. Meanwhile, physicist Carl Schwarzschild, serving on World War I's Eastern Front, used Einstein's equations to calculate that an object with sufficient density would create a bottomless PID in spacetime, a point of no return called the singularity. He also defined the Schwarzschild radius, the distance where not even light can escape, laying the theoretical foundation for black hole research. For example, if Earth maintained its size but had 250 times the Sun's mass, it would become a black hole. Tragically, Schwarzschild died in battle, leaving behind this brilliant but brief contribution. Over centuries, black hole theory developed and their existence became accepted, but direct evidence remained elusive. In 1978, French astrophysicist Jean-Pierre Luminet used punch-card computers to simulate a black hole's image. Later, for the movie Interstellar, physicist Kip Thorne helped generate a more accurate visualization. Still, these were just models, until April 10, 2019, when the Event Horizon Telescope collaboration released humanity's first actual black hole image, the supermassive black hole at the center of galaxy M87, 50 million light-years away. Though created from over 2 years of data processing, this image confirmed black holes exist, validating Einstein's theories, Schwarzschild's calculations, and Michell's original vision. The image closely matched both Luminet's simulations and Interstellar's portrayal. Current observations show nearly every galaxy centers on a supermassive black hole. In our Milky Way, it's Sagittarius, a star. Stars orbit it at incredible speeds, some reaching 24,000 kilometers per second, about 8% of light speed. This creates a galactic habitable zone. Too close or too far from the central black hole makes life impossible. Fortunately, our solar system sits perfectly in the Orion Arm, the sweet spot for life. Inside every black hole lies a singularity, as proven by Stephen Hawking and Roger Penrose. When a massive star collapses beyond a critical point, all its matter crushes into an infinitely dense, infinitely small point, similar to the Big Bang's origin. Here, space and time cease to exist as we know them, breaking all known physics laws. Interestingly, black hole singularities mirror the Big Bangs, suggesting our universe might also be finite, with a beginning, end, and limited total mass. Since we can't observe inside black holes directly, scientists study them by observing stars before they collapse. Some black holes may briefly expose naked singularities before their event horizons form. Near these, objects might accelerate beyond light speed, potentially jumping to other dimensions, Could these be natural wormholes? Speaking of wormholes, they're fundamentally different from black holes. While black holes are confirmed cosmic traps, wormholes remain theoretical spacetime tunnels, first proposed in 1916 by Ludwig Flamm and later developed by Einstein and Nathan Rosen in 1930. Imagine spacetime as a pond. Massive objects create ripples that warp its fabric.